Hello viewers, in today's session we are going to discuss another important problem from integration, and here we have to evaluate this integral that is from 0 to infinity, and we have x raised to 5 divided by 1 plus x cube raised to 5 over 2 dx. And here we are going to make use of the concept of beta and gamma functions to evaluate this integral. And before applying the concept of beta and gamma functions, let us first make use of the method of substitution to convert this integral into a beta function, that is beta m comma n is given by the integral that is 0 to infinity, and we have t raised to m minus 1 divided by 1 plus t raised to m plus n dt. So by a method of substitution, we'll first convert this integral into the beta function. So now let us first substitute t is equal to x cube, right? So that this term becomes 1 plus t raised to 5 over 2. So we'll take t is equal to x cube, and this implies that x is t raised to 1 over 3. So let us differentiate x with respect to t. So we have dx over dt is d by dt of t raised to 1 over 3, and making use of the power rule, we have nt and n minus 1, right? So here the value of n is 1 over 3, so we have the derivative of t raised to 1 over 3 with respect to t as 1 over 3 t raised to 1 over 3 minus 1. So this is 1 over 3 t raised to 1 minus 3 over 3 1 over 3 t raised to minus 2 over 3. So now dx over dt is equal to this expression. So now we can write dx is equal to 1 over 3 t raised to minus 2 over 3 and dt. So now let us change the limits accordingly. So here x varies from 0 to infinity, right? So when x is 0, 0 is the lower limit. The value of t can be obtained from this relation. So we have 0 cube, that is 0, and when x tends to infinity, that is the upper limit, then t also tends to infinity due to this result, right? So now let us write this integral I in terms of t. So we can now write 0 to infinity, and then we have x raised to 5, x is t raised to 1 over 3, so we have t raised to 1 over 3, and here we have 5. For dx, we can now write 1 over 3 t raised to minus 2 over 3 dt, and in the denominator we can write 1 plus t raised to 5 over 2. So now let us arrange the terms here, and we can simplify. So we can take 1 over 3 outside the integral. We have 0 to infinity. Then here we have t raised to 5 over 3, and here we have t raised to minus 2 over 3, and here we have 1 plus t raised to 5 over 2 and dt. So now we can write I is equal to 1 over 3 0 to infinity, and here we can apply the laws of exponents. So here the base is same, so we can add the powers. So we have 5 over 3 plus minus 2 over 3, that is 5 minus 2 over 3, that is 3 over 3, and that is t raised to 1, right? So in the numerator we have t raised to 1, and here we have 1 plus t raised to 5 over 2 dt. So now let us compare this integral with this one, right? So here we have 0 to infinity, here we have 0 to infinity, and t raised to 1. Here we have t raised to m minus 1, and here we have 1 plus t raised to 5 by 2, and here we have 1 plus t raised to m plus n. So let us find out the values of m and n in order to express this integral in this form. So we can now compare both these integrals. So we have m minus 1 is equal to, so we have m minus 1 equal to 1, and then m plus n is equal to 5 over 2. So let us solve this equation. So we have m is equal to 1 plus 1, taking minus 1 to the right hand side. So we have 2, and then taking m is equal to 2 in this equation, we have 2 plus n is equal to 5 over 2. So n is 5 over 2 minus 2, that is 5 over 2. This is 4, and 5 minus 4 is 1. So we have 1 over 2. So now we can write this integral I as 1 over 3, 0 to infinity, and t raised to 1. So 1 can be written as m minus 1. So m is 2, so we can write 2 minus 1, and here we have dt, and 1 plus t raised to 5 over 2. So 5 over 2 is m plus n. M is 2, and n is given by half, right? So now this integral is exactly of this form. So now the value of m is 2, and the value of n is half. So this is our beta function. So we have 1 over 3 times the beta function m comma n. M is 2 and n is half. So let us now calculate the value of this beta function with the help of this important relation between beta function and gamma function. So beta function is equal to gamma m times gamma n divided by gamma m plus n. So here we have 1 over 3, and then we can now write gamma 2. Then we have gamma half, and in the denominator we can write gamma 2 plus half. So we can now write the value of I as 1 over 3, and gamma 2 is equal to 1, because here we can use this result, gamma n plus 1 is equal to n factorial, where n is some positive integer. So if we take n is equal to say 1, then here we have 1 plus 1 2. So gamma 2 is 1 factorial, that is simply 1, right? And here we have gamma half. So gamma half can be written as square root of pi. So here we have square root of pi, and in the denominator we have gamma of 5 over 2. So now let us write the value of gamma of 5 over 2 with the help of this relation, that is gamma n plus 1 is n times gamma n. So here gamma 5 over 2 can be written as 3 by 2 plus 1. We can split 5 over 2 as 3 by 2 plus 1. So now our n is 3 by 2. So taking n is equal to 3 by 2 in this relation, we have 3 by 2 gamma 3 by 2. And further we can split 3 by 2 as half plus 1. So now we have 3 by 2 half times gamma half. So again applying this result to this expression. So now we have 3 over 4 gamma half is square root of pi. So substituting the value of gamma 5 over 2 as 3 by 4 times square root of pi, we can now write the value of I as 1 over 3. This is root pi, and here we have 3 by 4 times square root of pi. So these two terms get cancelled and we have 1 over 3 times 4 over 3. So we'll take the reciprocal of 3 by 4. So here we have 4 over 9. So viewers, the value of this integral is equal to 4 divided by 9.